Simplifying radical expressions, or sometimes called square roots. Here we have the square root of 200. Now let's remind ourselves on the perfect squares. To do that, we're going to multiply a number times itself. So 1 times 1 is 1, which is 1 squared. 2 times 2 is 4, which is 2 squared. 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. 4 times 4 is 16. 16 is a perfect square. 5 times 5 is 25. 25 is a perfect square. 6 times 6 is 36. 36 is a perfect square. 7 times 7 is 49. 49 is a perfect square. 8 times 8 is 64. So 64 is a perfect square. 9 times 9 is 81. 81 is a perfect square. 10 times 10 is, you guessed it, 100. 100 is a perfect square. 11 times 11 is 121. 121 is a perfect square. 12 times 12 is 144. 144 is a perfect square. And 13 times 13 is 169. 169 is a perfect square. At this level is wise to know the perfect squares, at least up to 15. 14 times 14, 15 times 15. Tell me in the comments what those are. Stick around to the end to get the answers. So here we have the square root of 100. We're going to factor out the perfect square. The goal is to factor out perfect squares. And as a reminder, factors are two numbers that are multiplied to get a product. Another way we can phrase that is a factor is a number that can be divided evenly into another number. So for example, 2 and 4 are factors of 8, right? Because 2 times 4 is 8. Or 2 can be divided into 8 evenly. That's how you know it's a factor of 8. And 4 can be divided into 8 evenly. That's how you know that's a factor of 8 as well. So here we're looking for a factor of 200, right? Don't forget our perfect squares. We can see one of the factors is 100. So 100 times what gives us 200? 100 times 2. Now let's be reminded of our principles of multiplication for square roots, all right? If the square root of A and the square root of B are real numbers, then the square root of A times the square root of B is equal to the square root of A times B. All right? So here we have the square root of 200. We can also rewrite that as the square root of 100 times 2. It's all underneath the radical. We call this symbol here the radical. And the number underneath it, the radicand. Now that could be rewritten as the square root of 100 times the square root of 2. Which is simplified as the square root of 100 is, of course, 10. And the square root of 2 will remain. It cannot be simplified any further. All right, the next, let's make that look a little bit better. 10 square root of 2 is our final answer. All right, next one. Square root of 98. All right, looking back at our perfect squares, 1, 4, 9, 25, nothing's jumping out at me. So we're just going to divide it by a number that we know can be divided evenly into it, and that's going to be 2. So 2 goes into, because they're both even numbers, 2 can go into 9 4 times. Get 8. We subtract 1, and then we bring this 8 down here. 2 goes into 18 9 times. Alright. We're going to finish our problem. Remainder 0. So the factors of 98 are 2 and 49. And as fate would have it, 49 is a perfect square. So we can rewrite our equation as the square root of 49 times 2. Make sure that's all underneath the radical, which could be, and this is a multiplication symbol, this should be a dot here, not a dash. Then we can rewrite that as the square root of 49 times square root of 2. The square root of 49 is, of course, 7. Square root of 2 is our final answer. 7 square root of 2. Let's do another. Square root of 75. Right away, we can identify that 25 is a factor of 75. How do I know that right away? Just thinking about money, thinking about quarters. 25 cents, 50 cents, 75 cents, $1. Whenever we are trying or multiplying by 25, just think in terms of quarters. So square root of 75 is equal to the square root of 25 times 3. 3 quarters equals 75 cents. If we rewrite that as square root of 25 times the square root of 3, which is equal to 5 square root of 3. All right, everyone, make sure your notation is good, all right? It's a good habit to make good notation when the stakes are low. That way we're already in a good practice of good notation when the stakes are high. We want to build good habits. Here we go. Negative square root of 80. All right, so here we have a negative in front of the radical. That's not going to affect what goes on underneath it because it's on the outside. Now remember the identity property. Any number is equal to 1 times that number, right? So n is equal to 1 times n. So if we had 4, 4 is also equal to, of course, 1 times 4. If we had 2011, 2011 is equal to, of course, 1 times 2011. 0, 1, 1. And in this instance, the negative square root of 80, let's take it back. Negative 5 is equal to 1 times negative 5, right? So we always know 1 times a number is going to be equal to the number. Here we have negative square root of 80. We can also rewrite that as negative 1 times the square root of 80. just to help us with recognizing the two separate expressions here. So we're going to just focus on the radical first. The square root of 80, we're going to use the same principles, factoring out perfect squares. So 4 is a perfect square of 80. Let's see, 4 goes into 80 how many times? Some of us are already able to figure it out. 4 goes into 8 twice. Four goes into 0 times. 4 goes into 80 20 times. So we rewrite that as -1 times the square root of 4 times 20. All right, now the square root of 20, we can break that down even further because 4 also goes into 20, which is a perfect square. So now we got -1 times the square root of 4 times the square root of another 4 times the square root of 5. Now where do we get 2 4s from? Well, the first 4 came from 80. 4 times 20 is 80. Now we bring that 4 down and we break 20 down even further. We simplify 20 even further and we get 4 times 5 to get 20. So we rewrite that as -1 times the square root of 4 times the square root of 4 times the square root of 5. Then we get -1 times 2, because the square root of 4 is 2, times another 2, because the square root of 4 is 2. We forgot our radical symbol here, times the square root of 5. The square root of 5 can be simplified any further because there aren't any perfect square factors of 5. And now we just simplify this. -1 times 2 is -2, and -2 times +2 is -4. So -4 times the square root of 5. We also could have just stopped here because the square root of a number times the square root of that same number is equal to that number. So for instance, the square root of x times the square root of x equals x. Or in that instance, the square root of 4 times the square root of 4 equals 4. Okay. And as promised, what is 14 times 14? You're right, 196. 15 times 15 is 225. Hope that you all work that out by hand. We want to make sure we are getting stronger with our calculation by hand. All right? Good job, everybody.